Hello, this is the June 2023 additional maths level 2 paper. I'm doing the second half today, questions 10 to 17. So hopefully you'll have a paper in front of you. You should be able to work out the questions from my slides. For lots of more in-depth videos, there are plenty on sessions 1 to 10, and I've gone through a couple of past papers. So this one starts with question 10, coordinate geometry. You'll definitely see questions on coordinate geometry. Distance between 2 points is generally Pythagoras' theorem. So as always, stop the video whenever you need to, go through the questions and I will discuss through them. So I do the distance between 2 points, and I do the change in x's first, and then I do the change in y's. It doesn't matter if I did -8 minus 4, and then if I did that I would do 1 minus 6, because you square them, they both work out the same. So this is just from Pythagoras' theorem. Very common question. Now the next one appears like I had a bit of an issue with my signs in there. So things like this we can all be careful with. I label all my sides as best I can. Any work I do with coordinate geometry because it's so complicated anyway, easy to make mistakes. So I've done m for gradient of AB. That's 6 minus 1. I got the 6 from here, from the y coordinate, take away the y coordinate. And then I don't know what I wrote down originally, but in the end I've corrected it to 4. But be careful, that says -8, so it's 4 minus -8. That would give us 5 over 12. But unfortunately that's not the end of the question, because it does say the perpendicular. So because I want the perpendicular, I have to change the sign to a minus, or the opposite sign, which means changing it to a minus, and change the denominator and numerator, because gradients and perpendiculars multiply to -1. So as I say, the simplest way is just to think about changing the sign and flipping the fraction over. All those are regular questions on these papers. In part B, find the equation. Then part dotty 3, do the coordinate of the midpoint. I just find midpoint very straightforward, although I've shown here in the formula, I just quite straightforward, go straight for the middle of the two numbers. Between 6 and 1, for the y coordinate, is quite clearly 3.5. Between 4 and -8, maybe not so easy, so it's worthwhile seeing the method. Midpoint very straightforward. You could see that in higher tier maths as well. And then for the equation, now the one thing with the equation, it does say it's got to be in the form y equals mx plus c. For occasion, we need a gradient and a point. Well, this one they've actually already told us the gradient, and they've already told us the point. Some years we might have to find the gradient first. Now every centre will do this differently. I use the formula m equals y minus y1 over x minus x1. Various reasons why people use different methods. Next thing I've then done, I multiplied both sides by x plus 3, so I get 4x plus 12 equals y minus 9. And then I'm trying to get it all on the same side. So I get y minus 4x minus 21 equals 0, but then I've just looked at the question again, and it needs to be in the format y equals. So there's nothing particularly difficult about these last 3 lines here I've written. It's just to be aware they've got to be in the correct format. Question 11. Another very, very common question, integration. Okay, hopefully you've been told the idea. To integrate, you increase the power and divide by the new power. It's sort of the reverse of differentiation. Differentiation tells us gradient, and integration tells us area between a curve and the x-axis for what we do in additional maths and A-level maths. So first I've got to integrate this. Increase the power divided by the new power, but you notice the last term, x is on the bottom, x is the denominator. So the first thing I've done is rewrite the question just at the top, just changing that into 4x to the minus 3. When it says the denominator, you put it as a numerator and change the sign. That makes it easy for me to integrate it all in one go. So the first line, increase the power divided by the new power. Minus 5, in theory it says minus 5x to the power of 0. Which then becomes minus 5x to the power of 1, but we write them as just minus 5x. Increase the power to minus 3, divided by the new power minus 2. Now if I stopped here, I'd probably cost myself 2 marks, because most importantly, when there's no limits, I've not put plus c. And more important in this question, it does say simplify your answer. I've not simplified my answer yet. Have a think about that line yourself, and I'll put my slide on for the next line. So 14 divided by 7 is 2, minus 5x, can't do anything about it. 4 divided by minus 2 is minus 2x minus 2. Don't forget the plus c. This term, the third term, I could have written as minus 2 over x squared. They're both acceptable. Alright, it's not the maths that's difficult, it's just that bit of care with reading the question to simplify. Now the next question is integration, but with limits. So it starts off the same. Now these questions are level integration is normally easier. So that's straightforward integration. But I need to put on the limits. Now my next line, I would have simplified it down. I don't have to, but I've simplified it down to make it easier for me to substitute values into the calculator. And basically the limits say anything up to 3 except anything up to 2. So I've substituted in 3, and except means take away. I've shown my working. It does say show your working. There are calculators, and certainly you need one for these at A level, where there's a button that does a lot of integration for you. Don't fall into the trap of just typing it straight into your calculator. You'll lose points. I'll let you work out where I got those numbers from. And that minus 32, that minus is the plus 8 there. The minus times the plus makes that a minus. Give me the nice round answer of 140. Again, really regular question. Now the next question is 3D. And whenever I do any 3D trig or Pythagoras, I always tell my students to draw 2 right angle triangles. Without fail, it seems to work on most of the questions. I think it's another one where it works, as you'll see in a minute. But if in doubt, draw your 2 right angle triangles. The type of thing I like to do is label the corners, help me understand what triangle I'm working on. Now, each of the shape questions that are on these papers, they're all different. Okay, you can have curves, you can have spheres, you can have hemispheres, cones. This one is just a triangular pyramid, sorry, a square based pyramid. So first of all, you'll see I've drawn a picture, putting some key letters on. I've called it T for top, A, B and C, it's up to you. I've called M for the midpoint. I need to calculate the angle between the diagonal of the base and the 6 centimeters. So I've got to try and calculate the angle between the base, which is AMT. AMT. So hopefully I've drawn a right angle triangle up with some of those letters in. Or I might have done BMT, and it won't matter, but because the original picture has the loop in, the arc in at B, I've drawn the triangle BMT. But before I do BMT, I need to know something else. And you might be able to see this bottom triangle, I've got A, C and B on. So hopefully that's the first triangle I've drawn. Let's click on my slide. I've drawn out ABC, so keep referring back to the original slide of the picture. And I've worked X out, which is the length of the diagonal. 3 squared plus 3 squared, straightforward Pythagoras. I've written half root 18. Why didn't I press that using a calculator? And doing root 18, it won't give me a precise enough answer, and it might cost me a mark in the end with accuracy. So always try and leave your square roots to square roots. Right, why did I half it? Because if you notice, AB is the full length of the diagonal, but we only want AM or BM, so that's why I've halved it. So as I said, next thing I've drawn another right angle triangle out with T for the top. You don't have to label any of these, it's just for me to explain to myself and to my students how they've worked out the answers, and to any of you get any idea. Now I put H here for hypotenuse and A there for adjacent. So I've done cos theta. I typed in my calculator half root 18 and it simplified it to 3 root 2 over 2. So I've done that divided by the hypotenuse, which is 6. Or as I've shown it on the right hand side, I left it what I originally put. Shift cos, whenever we find an angle, that's in pretty much any level of maths, you're always going to press the shift or the second function. Gives us a nice answer, 69.3. So although I can't swear one of these questions will be on every year's exam, they're pretty common with triangles, and again you'll see this at GCSE higher tier, so it's good practice for that. Now I often say, question 13, I often say with additional maths, part of it's GCSE higher tier and part of it is A level, so that's why it's a good mixed exam. This question is classic A level, unit 1 that you'll do in year 12 in AS maths. Find the x coordinate and the nature. Now the nature we'll get to in a second. Stationary points. Stationary points I always say is like the top of a roller coaster or the bottom of a roller coaster. When you get to the top of a roller coaster, for a split second it feels like you're not moving, you're stationary. And when you're at the top, that means the gradient's actually worth 0. So for my opening line, I always get my students to write for stationary points dy dx equals 0. Don't have to do that. Lots of sentences will just tell you to differentiate, but that's why I do that for mine, to explain why this works. The stationary point, the gradient is 0, we just flatten out as we're at the top of the roller coaster or at the bottom. So I've differentiated, same as you've seen on other videos, 3x squared over 3. Now my next line, I would have simplified all this because 3 divided by 3 makes my life a lot easier for me. So my next line, I've now used the 0 instead of dy dx. Very straightforward B grade GCSE maths here. And I've found my x values. X equals -5 or x equals 3. Now, you'll notice I didn't write the y coordinates. In the question, instead I need the x coordinate. Don't be fooled by this. Most years you do need the y coordinate as well. This year we didn't. I did work out one and I realised I didn't need it. So I put in brackets what I would have done, sub in y, but it wasn't needed in this question. So that's how I found the x coordinates to the stationary points. Now different centres will teach it differently. Some centres might tell you to do d2y dx squared as soon as you've done dy dx. I don't do that anymore. So this is what I've done for my next part of the question. They don't call it part B, but the part B type, the nature. So I've written nature in, and this is when I do d2y dx squared. Now I've got that to be 2x plus 2. All I've done is differentiated the dy dx again, very similar to we did on question 9 on the same paper. The level of differentiation is not that difficult in these questions. Level of differentiation is more difficult in pure differentiation questions. So d2y dx squared. And then I substitute in the two values from earlier that I found for the stationary points. Now the key thing is to remember when it's less than 0, you get the maximum at x equals -5. I'm not particularly happy the way I've written this out because I've written two equals on the same line, which isn't great maths. If I did this again, I would have written out d2y dx squared equals -10 plus 2, and on the line below I would have written equals -8. That's less than 0. That means we have a maximum. Lots of centres might tell you to call it a local maximum. That's fine as well. At x equals -5. Now the other one, by substituting the other number, x equals 3, d2y dx squared equals 6 plus 2 equals 8. Again, I've done the same thing as I did earlier. I would have written equals 8 underneath if I did this again today. That's greater than 0 when I get a minimum x equals 3. Now I'm not going to explain why, but generally on most of the A-level type questions and the additional maths questions, if d2y dx squared equals -1,000,000, then the other one will work out as +1,000,000. Okay, it's to do with the nature of the questions. That's not what this is about. It doesn't always happen, but the majority of the time it does, so it just gives me a bit of confidence that these are the right numbers. Okay, and that's the end of that question. Maximum and minimum. You can't have two maximums and you can't have two minimums. So if you do, that's a sign you've gone wrong. You could only have two maximums and two minimums if we had minimum and maximums in between, which we won't get on additional maths. Now, question 14, first principles. I keep saying the types of questions are always on these papers. This one's been on every paper since 2011 when this course pretty much came to an existence. There was a pre-runner of that. Y equals 3x squared plus 4. Now, this is one I would refer to how your centre does this, but several centres will do the way I do, and this is not even appears on the official mark scheme, but I have checked that it's acceptable at the WJC and they're happy with the method I've used, and several other centres use this method as well. So I use dy dx equals the limit as h tends to 0. That means h gets close to 0. I use x plus h. Other centres will use x plus delta x, the same thing. Other centres will start off in a totally different line. So if you've got another method that you use in your centre, I'd probably stop watching the video now and move on to the next question because it might confuse you. But for those people who do something similar to this, classic mistakes people make, they put lim before the equals. I've seen that too many times. Now my next line equals lim again. It's the way I get my students to write the answers down. But you'll find anything that's in the bracket must simplify with anything in front, because if it doesn't, that means you've gone wrong. That's the whole point of differentiation, first principles. So minus 3x squared minus 4 is simplified out with the original 3x squared and the original 4. Now this is now just leaving me with h's on the top and h's on the bottom. Again, if you get a term without an h on the top and an h on the bottom, that means you must have made a mistake. The gap between my limit and my fraction here is getting a bit too big, so I wouldn't be particularly happy with that. I'd like to keep that a little bit closer. Now, dy dx, limit h tends to 0 is 6x plus 3h. Several centres might well get you to put 3, 0 in. I wouldn't, because it's not actually correct, because it doesn't exactly make 0, but it's close to 0. So you want to think if it was close to 0, what would it become? And 3 close to 0 would be worth 0. So you'll get down to my final line, which is just dy dx equals 6x, because the 3h has disappeared. Now, some students might be familiar with just differentiating in the first place and going, the answer has to be 6x. And I've seen centres do this, where they write 6x at the top straight away, so they know what they're working for, which is a good idea. And as I said, we've got 6x, I'm confident that's the right answer. This one topic that has to be written out perfectly for you to attain 5 full marks on exam session marking. Final time, as I say, use what your centre does, because there are multiple methods. Next one's question 15. You won't get exactly like this at higher tier, but normally in higher tier maths you're asked to draw things like 3 sine x, or occasionally sine 2x, or sine x plus 1. So it is linked to higher tier. They put some numbers on. When I've drawn my original one, I put these numbers on. I substituted in 90, 180, 270 and 360, and they all worked out on 0. So I had to reflect and thought, what else should I do? And I thought, well, see, it says sine 2x, I halved the 90s. So I put all the numbers in the middle. And when I do this type of question, I draw all the crosses and then I join them up. It's not the best drawing I've ever done, but would certainly get me the marks. The other mark is for putting the maximum height and the minimum height. So really, this is very straightforward using a calculator, substituting the values in. Say this question did do 90, so it might be slightly off putting it they're all 0, so that's what I did in the middle. Now next thing says find the solutions. I've got 3 sine 2x equals 0.77 from the question. My next line, I've done sine 2x, I've just divided everything by 3. Now whenever you press shift sign, or shift cos or shift tab, but in this question shift sign, you need to come up with a list of answers. Now again, each centre will do that differently. I've seen all silly teacups. I've seen people draw the original graphs of sine 2x, for instance, on this one. This graph is 3 sine 2x. It might be slightly misleading if you use this one. I've also seen centres say the partnerships add up to 280 or 540, but I'll let you think how we did that. So this really ideally would have said 2x in the front equals 15.01, because I've shift signed from that. And then to finish off, I divide all the values by 2, leaving me these 4 values: 7.5, 82.5, 187.5 and 262.5. Again, this is a common question. And it's maybe slightly misleading what I teach at higher tier maths and what I teach at A level. So be careful how you draw the graph and then link to the right hand side what I've done. As soon as I press shift sign, this is 2x. This isn't sine x, which you normally do in higher tier maths. Okay, so this graph might be slightly off putting. One of the answers at 15, but then the next answer is 164, which won't show up because this graph is 3 sine 2x, not sine 2x. Next question, as I mentioned earlier, integration tells us area between the curve and the axis. On WJC case, additional maths between the curve and the x-axis. Find the area. Now the one thing I've got to be a little bit careful is we've got a minus number here. So I've integrated. Oh no, actually I apologise. The first thing I've done is actually find out x, the values here. Sorry, what do I know about these values here? I know that y equals 0. So I've substituted 0 in for y, and then I've rearranged to get x squared on the front, which is what I would normally show candidates in GCSE maths. I factorised, a lot of factorising in this paper. I got x equals 9, x equals 3. Now my next slide explains why I did x equals 9 and 3. I now put 3 and 9 on this question. It shows me to integrate, but now I have limits. You'll always get an area question on one of the additional past papers. Often they will give you the limits. This one didn't. You have to calculate yourself first. So now we get to the integration section. If you integrated without the limits and did your usual steps, you can still score 3 out of 7 marks. So integrate as we did earlier, increase the power, divide by new power. Substitute your values in. Putting the top number in first, the second number in second, and it gives you the nice answer of 0 minus here, minus 36 from this bracket, which leaves us with the answer 36. Again, if you're preparing for this type of exam, you will see these on every single one of the past papers. Very common question. Leading us to the final question, which is to do with equations of tangents to curves. Now, to do an equation, I would tell all candidates you need a gradient and a point. Well, we've only got half of a point here. We've only got x equals 2. we need our y coordinate. So I substituted x equals 2 into y equals this. That gives me 1 mark for getting the number 16. But the next thing I need to know is the gradient, and hopefully you're familiar with the term dy dx meaning gradient. So as I would always get my candidates to write down for an equation, I need a gradient and a point. I've got the point, now I need the gradient. To do the gradient, I differentiate the original function. Give me 10x minus 3. Don't forget the differential of 2 is 0. And then I've substituted in this value of x equals 2. Giving me the gradient now of 17. Now, as I said earlier on in these slides, other centres will do this formula different to me. Several centres will do y minus y1 equals m open brackets x minus x1. But I do it in this format more for when there's fractions, but it doesn't matter, it will work out the same thing. So I've got m is 17 from my working over here, the gradient, y minus y1, that's why I need the y value. If I hadn't come up with that, I would have gone back and worked out for this line. My next line, basically I've done m open brackets x minus x1, I've done 17 times x minus 2. Because y minus 16, again, I've been guilty of this before, I've carried on without reading the question again. Write it in the form ax plus by. Now don't panic, they say pluses, they don't have to be pluses. Leaving me with a final line of 17x minus y minus 18 equals 0. And the correct format. You will definitely see these on every single paper that's been so far. Now, hopefully that will help you with another set of papers. Remember, there are lots of topics for lots of subjects within the Carlin-Cymru family, for lots of subjects written basically around WJC, which is why it's useful for our candidates in Wales. Good luck.